Continuing on with section 2.1, we're now doing one that has a fractional function, and it's called a rational function because we know that the domain of this guy is what? Domain is a can't equal, right? Because it's undefined. It is a asymptote and an asymptote. I know English barely. Okay, so is everybody comfortable with that? All right, that's why we're doing this one. You'll get one too, and it might be a little bit different, but it's the same venue, if you will. So everybody ready? So we're going to take our difference quotient, and that's the limit as h approaches 0. And we're going to have our function as 5 over x plus h minus 5 over x, all divided by h. Ready? Everybody comfortable with that? Now, there are several ways to get a common denominator and remove the h automatically. But I think I'm going to just do the top part as a common denominator and then deal with the bottom. Okay, so what we're talking about is an LCM, least common multiple of the denominator. And of course it is what? X times x plus h. Does everybody agree? All right. So if it's that value, then what I have here is going to be 5 over x plus h times x over x, right? Is everybody clear? And then I'm going to have minus 5 over x times x plus h, because this one's missing the argument. Now, those of you that are math savvy would have multiplied the top and the bottom by the LCM, and it takes care of everything. But it won't hurt us to do the math. Okay. All over that h. So as we do our beautiful math, I'm going to have 5x minus, and I'm going to distribute this through, and I'm going to have to put parentheses, 5x plus 5h all over x times x plus h times, now, okay, on a complex fraction, we have the fraction over 1, and we multiply by its R word, reciprocal. So this is going to be 1 over h. Here we go. Let's see what happens. I don't know. All right, so we're going to take the limit. H, have I done any math errors yet? Okay. This one, like I said, is unique. It's a rational. So I'm going to end up with negative 5h over x times 1 over h. Now we're going to cancel out our h. All right. Now we have the equation. We take the limit as x approaches 0. So if I take this limit, this is 0. Does it affect anything? No, it's still x. Does everybody see it? It's an x squared to be exact. So we have, as a result, the change over y over the change over x as a function of negative 5 over x squared. All right. So this is our slope if we substitute it with negative 4. So That was negative 4 squared. So I'm going to get a negative 5 over a positive, what, 16? Ugly, but it's doable. Everybody good? All right. Did I lose anyone in the math? One in the math. I think it looks about right. Why did I get rid of it? By cross canceling? Oh, H approach. I took the limit. H is 0. That's a good question. I thought maybe I wasn't clear. Ask them. If it's a plus H, I'm not concerned. It's when it's a multiple of H or an H in the denominator. Everybody good? Here we go. So I have my slope, and we want the tangent line. The minus. Right. We're going to do a little bit math. My favorite, fractions. Remember, they're our friends. This is a plus, so it's a negative. And it's going to be a negative 20 over 16. We're going to reduce that. It comes out clean. And this is going to be reduced by 4. So it's going to be a negative 10 fourths. Comfortable with that? You understand? Huh? If you're always a question, and with me, you should be. So we could stick the whole thing here, the fraction that is, if we had the what? Negative 20 divided by 16 minus the 5 divided by the 4. And we get this ugly thing. And we're going to do the math frac. And we get 5 halves. I didn't reduce it, but yeah. So any way you want to go at this level, permissible. Is that y'all clear? All right. So now we would check with the calculator. Right. Let's see what happens there. It's a weird little function. 5 over x, wasn't it? I don't know. I could make a mistake, and that's, I don't know, probable. And then we said our function is negative 5x divided by 16 minus the 5 halves. Okay, and our point was small. You see how our point was small? It is just barely over 2. So we're going to go to our window, and it's negative 4, so we're definitely going to put more negative in it. We're going to say, let's say negative 8, 5, just for grins. And the 3 is fine, but the positive cannot be 100. So we know our point is at 1 1/4 negative, right? So we covered it with the negative 3. So we're going to put this as a positive 3, and let's see if it works. There it is. Beautiful. Absolutely beautiful. Of course, the asymptote is at x equals 0. Everybody comfortable? Okay, now how do I check? Everybody do the second calc on it and put in that -4 for me, but I can tell by looking at it I did a pretty good job. But everybody check. It's your job. You want to be sure about your answers as best you can. Not everything will come out beautiful, but it will come out pretty clean. All right. This is a distance time graph of a muscle car accelerating at a standstill. All right. They do this in Tesla has this done because they want to know what the acceleration is. And what's their new car that's very fast? Goes 60 in 5 seconds. Oh God, we were just talking about it in the car. My grandson is a car fanatic, and Tesla has a sports car, and it'll go 60 in about 5 seconds. The problem is it's got the engineering on it is not good enough. So the gas pedal, if you're going really fast, will get stuck on the bottom, and you're stuck with it fast. So they're correcting some things, but again, engineering is precise, and they do these tests before it gets on the market, but you never know about production of something that defined. You know, what they used to say that the Mercedes were hand built because they could, as a technician, they could make sure that everything was correctly from the distance. Yeah, the first Mercedes for the what about 30 years were hand made. There was another one that was a 16-cylinder or 18-cylinder race car. Anyway, I digress. Okay, so we have ordered pairs, and we want to show the distance time graph of the muscle car accelerating from standstill is. The coordinates are 9 3/10, and I'm guessing this is in seconds, 204 or maybe minutes. That's kind of big. Definitely a lot of movement here. And then all it keeps on going up, doesn't it, as the time lapses. The slope of the secant line from P, okay, from P to Q2. All right. So that means that we want the average rate of change. Average, because we've got 2 points, right? So we're going to have P minus Q over the value distance. All right. And that's just that X of P. I'm not going to write all of it. So here we go. So we're going to put the 650 of this and subtract the 393 and then do what? 20 minus 14 and a half. Okay? Does everybody see where I got? It told me P is the end from that part. Is everybody good? All right. So then we would do simple math. The argument to be complete for each part. And we would round. So the average rate of change for this guy, because we don't know the units, is just the number. Now, I think on the computer, your homework, they asked for 3. But I'm just going to do 1. Is everybody comfortable with that? I think that's fine. This is from P to Q3, and that would mean the 650, it's the P to Q3, 559 over 20 minus the 18 and 2. Is everybody comfortable with that? And then the last one is P to Q4. And now they're taking what the times that they're judging are smaller and smaller. and then they're evaluating the secant versus the closer we get to a tangent. Is everybody comfortable with that? So this guy would be the 650 minus the 1,604. No, I'm sorry. 604. Oh my goodness, my eyeballs. Sorry about that. From 20 minus the 19.1. The 19.1 blew me. It just blew me. So we would do these in this particular problem and get the answer. Is everybody comfortable with that? And they show you, I gave you the graph. And so now from these guys, you would get an approximate, and that would be the average of whatever outcomes we have here. You would take an educated guess. All right, that's that. And oh, I have this one here too. Where am I? Let's take a break, and then we'll come back and do this. Is everybody comfortable? Everybody get up, take a break. I thought I erased everything. Stretch, go do things, do all that good stuff.